Let's talk about vector. You have probably read in the notes that vector consists of a magnitude and a direction. And the notes also mention that we can represent vectors with a vector arrow. So, well, here I have a blue arrow here, and this blue arrow here, it's actually representing a vector. Okay, so vector consists of magnitude and direction. How do you represent the magnitude? You represent it with the length of the vector arrow itself. The longer the vector arrow, the larger the magnitude of the vector. Okay, so this represents magnitude of vector, and because the magnitude of vector is technically just the length of the arrow, we don't really care where the arrow is pointing, so it's just a length, so there's no negative length in this situation, so magnitude of vector is always positive. Again, magnitude of vector is always positive, but magnitude, let's say scalar quantity, only consists of magnitude, right? Scalar quantity's magnitude can be negative. Okay, let's say temperature, you can have negative temperature. Even though it's a magnitude, you can have negative magnitude, but that's magnitude. Here, I'm talking about magnitude of vector. Magnitude of a vector must be always positive. Okay, so vector besides magnitude also has direction. So which angle is it pointing? That represents its direction. Okay, so that's why this arrow here, because it can correctly express its magnitude and direction, we can label it as a vector. Okay, so this arrow sign on top must be pointing to the right. It's a symbol, it's a hat for this S to wear, and this hat is a right pointing arrow. And if you see this arrow on a physical quantity, that means that physical quantity is a vector. Okay, so if you want to write it in words or write it in mathematical form, you can probably write it as S equals to 5 meter. But if you think that's correct already, no, that's actually incomplete. Because if I write this symbol here with an right pointing arrow on top, I'm clearly stating that this S is a vector. But if I just write equals to 5 meter, I'm only stating the magnitude only. What's missing? I'm missing the direction actually. So in that case, right, this statement here is actually incomplete. I have to include the direction of the vector as well. And actually, that's the main topic for today's video, how to determine the direction of vector. Okay, so to determine the direction of vector, what we do is we put this vector arrow on a Cartesian coordinate axis. Okay, a coordinate axis. So a normal Cartesian coordinates usually have negative x pointing to the left and positive x pointing to the right, whereas you also have negative y and positive y. Negative y pointing downwards, positive y pointing upwards. Okay, so what you do is you place your vector arrow with its tail on the origin. Okay, if it's an xy axis, the center of it is called an origin. We place this vector arrow with its tail. This is a tail, this is the head, this is a tail. We place the tail at the origin. Okay, so once we have done that, what we do is we measure the angle between the vector arrow and the nearest x-axis, not y-axis, nearest x-axis. Okay, we want to find the angle here. Okay, so let's say we measure using protractor or some kind of device and found it to be 45 degrees. So what we do is we can we can define the direction as 45 degrees. But if we just write 45 degrees, no one knows 45 degrees from where, and that's what you need to elaborate at the back. Okay, so there's two things that you need to elaborate when you are writing the direction of vector. First thing is whether it's above or below the x-axis. So this is the region of our vector arrow, and as you can see, this pink region here, it's above the x-axis, right? This is the x-axis that we have here. If the pink region is over here or over here, that's below. If it's over here or over here, that's above x-axis. So in this case, we know that our 45 degrees above the x-axis. And the next thing that we need to know is whether it's above the positive side of the x-axis or the negative side of the x-axis. As you can see here, this part from the origin to the left, it's a negative x-axis. Whereas from the origin to the right, that's the positive x-axis. And our pink region here happens to be at the positive side of the x-axis. Therefore, we can complete the sentence by saying that it's above the positive x-axis. Okay, so what do you need to have when you're writing direction? The first thing you need to have is the angle. Second thing is whether it's above or below the positive x-axis. There's only above and below. There's no left and right. There's only above or below. Okay, and writing another alternative is below. Okay, then the next thing is whether it's the positive side or the negative side of the x-axis. That's the third thing that you need to write. Then the words behind is always x-axis. We usually do it using x-axis. We never really do it using y-axis. Okay, so 3 things I need to write: angle, above or below, positive or negative. That's how you define the direction of a vector.